Let's go. Okay, so we're going to be doing 7.1 notes about trig identities. And if you need to pause and write things down, do that, because I'm not going to make a 85-minute long video. Y'all just pause it when you need it. Okay, so 7.1 trig identities. Remember, trig is like sine, cosine, tangent, that kind of thing. First, let's figure out what the heck is an identity. Well, we know one identity. We know this guy, he's got like glasses and some suave hair. He's pretty good looking. And at night, he's like this thing. Oh gosh, I don't, what? Anyway, he's Batman. Yeah, Clark Kent and Batman. Like or Clark Kent is Batman's secret identity, like they're the same person. They just look two different ways. They perform two different duties, but they're the same person. They just look differently. When we do like algebra, say I have 2x plus 3x. This is the same thing as 5x. They look different, but they're technically the same thing. Those are identities. Or like the number 2/2. That's equivalent to, or that's the same thing as the number 1. They look different, but they mean the same thing. Or square root of x and x to the 1/2. They look different, but they're the same thing. Or in trigonometry, let's see here, sine over cosine, sine theta over cosine theta, that's the same thing as tangent. What? X over y, yeah, what? That's an identity. They look different, but they mean the same thing. Or I think also in the last chapter, we randomly dealt with this equation, cosine squared theta plus sine squared theta equals 1. I think we use that every once in a while. This is an identity because the left side is equal to the right side. Remember, this is where we plugged in points or something from the unit circle and we squared them. And like if we did x squared plus y squared and it was equal to 1, then it was on the unit circle or something. Anyway, I don't know, but this is an identity, just like Clark Kent and Batman. Sine over cosine and tangent, that's what an identity is. And we use identities to simplify. What? Simplify things. What the heck does the word simplify mean? It means make things smaller. Like if you had 18x squared minus 6x squared plus 4x squared, that makes 18 minus 6, 12, 12 plus 4, 16. 16x squared. Hey, we just simplified that beast by making it smaller. Or simplify also means change things. Like this x squared to the cubed. That's when we multiply the exponents and you get x to the 6th. What? We just simplified that. The numbers became bigger, but we actually simplified it. Or over here, 27 over 3. Oh, another way to simplify things is to make things easier. Like all this hooey just looks janky and scary. But if we actually work the fractions out, 27 over 3 is 9, plus 18 over 9 is 18 over 2 is 9. Tricked you. 10 squared is 100. This makes 118. Oh my gosh, we simplified. Yeah. So simplify means make it smaller, change it somehow, make it easier looking, all by doing legal math. Or replacing. That's another way to simplify. This is like a SAT kind of question thing. If A plus B equals 8, then what is 2 times A plus B? Well, hot dog, you're right, Wiper. You just take this 8 and you plug it where this a plus b is. You say 2 times 8. Hot dog, it's 16. So simplify also means where you take something you already know and you replace it with something else. So like this a plus b, I knew it was 8. So I replaced that a plus b with the number 8. So let's talk about simplifying identities. How the heck do we do this? How? Well, when we're doing these trig identities, sine, cosine, tangent, blah, 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 usually the first step is we change everything to sine and cosine. Usually. And then after that, it might take Miss Morrison 1, 2 steps, and then I'm done. Hallelujah. Or it might take Gracie Wright 1, 2, 3, 4 steps, and then she's correct. So these simplifying identities, all this stuff in this section, you're not going to be doing exactly what your little buddy is doing. Emily, Tiny Hands, she might do 1, 2, 3, 4. Oh crap, I backwards, 5, 6. Oh no, she goes in a circle. 7. She made it, and she got the right answer. Whereas maybe Tanner Kimbrell says, oh, well, I just did this one step and I'm done. So there's lots of ways to simplify using these identities. As long as you do your work right, you'll get to the answer. It just, for some of you, it might take 2 steps. For some of you, it might take 18 steps because you accidentally go backwards and then you go in a circle and blah, 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 blah. Have I been talking for 7 minutes? Oh my gosh. Okay, so the next thing we need to do is write down the identities. You know some of these already. We just talked about that tangent is equal to sine over cosine. Yeah. We also talked about the fact that sine squared theta plus cosine squared equals 1. Yeah. So take a minute to write these down. I'll read them real quick. Reciprocal identities: sine theta equals 1 over cosecant. Cosine equals 1 over secant. Tangent equals 1 over cotangent. Cosecant equals 1 over sine. Secant equals 1 over cosine. Cotangent equals 1 over tangent. Then we have our quotient ratios, which are tan equals sine over cosine, or cotan equals cosine over sine. Then we have our Pythagorean identities. Sine squared plus cosine squared equals 1. And I keep dropping off the theta because I'm lazy, but you need to write it down when you write it down. Then this one says 1 plus tan squared Gracie Brockway. Tan squared Gracie Brockway. Theta equals secant squared. Then 1 plus cotangent squared equals cosecant squared. So all those, there's some kind of new ones, but we've seen some of them before. And then there's these strange even odd identities. And all these do is it takes a negative in the parentheses and does something with it. So the odd identities are sine and tangent, because if you have a sine of a negative angle or sine of a negative theta, whatever, the negative just plops out in front. Same thing for tangent. If there's a negative inside the parentheses, it plops out in front. The only one different is cosine, because he is even, and with cosine, the negative in the parentheses just disappears. And I don't have it written here, but the reciprocals are going to go in here also. So for example, sine's reciprocal is cosecant. So cosecant is also odd. Tangent's reciprocal is cotangent. So that means cotangent is also odd. And then cosine's reciprocal is sine. So what the heck am I trying to say? What? No. Cosine's reciprocal is secant. Idiot. and secant is even. Okay, so write these down. I'm out.